It's finally time to do some exercises involving strings. And you may notice from previous videos, there have been a few cases where I've had to veto an exercise that ChatGPT suggested because it involves strings and we hadn't learned them yet. So now we have. Hopefully it still remembers some interesting string exercises. And I will add that it does tend to be the case that people want lots of practice involving strings. So, I mean, hopefully that means you're watching this video, I guess. And that even though the course has more technically complicated or conceptually difficult material in it, it seems like at the end of the course, when all is said and done, when the final exam is over, people often report that the string questions on exams or the assignments involving strings are the most frustrating, because working with strings is a bit of an acquired taste, and there's a lot of things you have to think about that aren't obvious. There's a lot of debugging you have to do that is sort of lurks, the bugs can lurk underneath the surface. So hopefully these exercises can help a bit with that. So we'll go over and ask ChatGPT. I just learned about strings in C. Can you suggest 3 programming exercises involving strings? Of course! So enthusiastic as usual. Okay, we'll take a look at what it came up with. String length calculation. So write a program that takes an input string and calculates its length. So I know that I've done this exercise in a lecture by now. So this is I actually have videos where I've already solved this. So I'm going to veto it because it's not really uncharted territory. It's something I've already done. I'm just going to ask for a replacement of that. Number 2, string reversal. Create a program that takes a string as input and reverses it. For example, if the input is the word hello, the output should be this, which is the word hello spelled backwards, obviously. You'll need to swap characters from the beginning and end of the string while working your way towards the middle. That's an interesting sort of clarifying sentence. So I interpret this sentence here as saying that I need to perform the reversal in place, which is sort of good because by now there are other videos of me, and I've done in class, string reversal using a second array. So a couple of videos ago, ChatGPT gave me an array exercise that was reverse an array, and I will use the same logic as I did in that video in this one. So if you need to know how I did it, go back a couple of videos, look at the array exercises. But as I mentioned then, performing this transformation in place, so not creating a separate array, I think makes the problem a little bit more difficult. I'm going to ask it to clarify that that is what it wants me to do. It wants me to perform the reversal in place. Exercise 3, string palindrome check. Write a program that checks if a given string is a palindrome. That's it then defines palindrome. A palindrome is a string that reads the same forwards and backwards. So for example, and it says, this is interesting, ignore spaces, punctuation, and capitalization when checking. Okay, I'll have to come back later and ask it for a bit of clarification about what it means by punctuation. So it's saying that this word, race car, is a palindrome. But this entire phrase is also a palindrome, even though, of course, so if you reverse this, you can try working this out on paper. If you reverse this phrase is actually a palindrome if you ignore all the spaces and if you treat uppercase and lowercase letters as equivalent. If you don't do that, if case is important, then this uppercase A and this lowercase a are, of course, not equal. So it's not a palindrome in that sense. This is actually a more difficult version of, I think, a pretty classic palindrome checking exercise. So I'm excited about that one. It mentions remember to handle memory allocation properly. Now, the way it's using this term, we'll talk about memory allocation later in the course. I don't expect to need to do any dynamic memory allocation, so I'm not going to worry too much about this. Avoid buffer overflows. Okay, well, that is a big deal. And use appropriate functions for string manipulation. So it's telling me, I guess, that I should be using the library functions in string.h when I want to manipulate strings. I shouldn't be doing everything myself. And I'm going to try and take that into account when I'm writing my solutions. Now, what about my clarifications? Okay, first, I need a replacement exercise for exercise 1. Exercise 1 is a bit too well, actually, I won't say too easy. I've already done exercise 1. Can you suggest an alternative? And you know what? If people consider string exercises to be frustrating, then I guess I should share in that. Let's have it create an exercise that I'm going to have a problem with. Let's see if we can make me suffer a bit. I want a really difficult string exercise. Okay, Let's dive into a more challenging string exercise. All right. Exercise 4. Okay, this is already looking pretty interesting. Exercise 4, anagram grouping. An anagram is a word or phrase formed by rearranging the letters of another. Okay, it looks like there's some examples down below. In this exercise, you'll write a program that reads a list of words from the user and groups the anagrams together. So for example, if the user inputs listen, silent, hello, world, hit, if, okay, then the program will output this. So the word listen and the word silent are actually anagrams of each other. And that's, which I know because I've put that on exams in the past, as it turns out. But I think that's a pretty clever pairing. And then you can see here what apparently I'm supposed to do is read a whole bunch of words from the user, word by word, and then print them out in groups. Where everything in a group is an anagram of everything else. So you can see here that hello isn't an anagram of anything else, but hit and whatever if means, those are anagrams of each other. Okay, so I can see in advance, I'm going to do this exercise because I wanted it to make me suffer. I'm going to need to make a couple of assumptions in doing the exercise that are a little bit above the level of the course, I guess. They're not, I think I can do this entirely with material that we've covered so far. I'm going to have to, I don't know, employ a little bit of knowledge that I have anyway, make a couple of assumptions using some design techniques that might not be obvious to all of you. But hopefully all of you will give this exercise a try anyway and see how far you get. The issue of reading a list of words from the user, that's something where that problem is a little bit difficult to wrangle in C. There are a variety of ways of doing it. I'm going to find a way of doing it using only what we've seen so far. And the compromise I'm going to have to make is to only read a certain number of words. So I'll have some maximum size of list that I can possibly read from the user. All right, so I want to ask for a couple other clarifications. One of them is for exercise 2. For exercise 2 above, am I correct in assuming that you want me to reverse the string in place? So exercise 2 implies that I'm going to need to swap characters around, which makes me feel sort of like what I'm supposed to do is modify the string without creating a copy of the string. So I'm going to ask it for that clarification. Okay, so, oh, actually, it's saying for exercise 2, I could do it either way. So it's not requiring me to do it. It's apologizing again. Okay, it doesn't need to apologize. It's doing a good job. So it says apparently I'm allowed to choose either to use a new string or to do an in-place reversal. I'm going to choose to do it in place because I believe that by now I've already done the exercise using a new string in front of a lecture. So for the sake of some variety, I guess I'll do it in place. And what else was there? The palindrome check. Oh yeah, I have to ask it later what it means by punctuation. I think I'll come back to this when I do that exercise. So let's get started with exercise number 2 because exercise 1 we're skipping over. Exercise 2, string reversal. Okay, so we'll go over here, we'll install our exercise. There we go. So this is a program that takes a string as input and reverses it. And actually, I'm noticing ChatGPT seems to have gotten confused about its own punctuation. You'll notice that in the example it gave, it puts this comma inside the quotation marks, but in the reversal, there's no comma. I think it's because it put the punctuation on the wrong side of the quotation marks because it's writing it like it's a quotation in the middle of English text, not like it's an input example. So I'm just going to make that clarification. I'm not going to go bother arguing with it. I'll just make that correction myself. And then it suggests that it makes this odd suggestion that I interpreted as a suggestion that I perform the modification in place. Okay, so it takes a string as input and reverses it. So I want to create a program that does that. I'm going to start by having the string that it takes, so I'll just call it S. I'm going to have the string just be a string that was created directly inside the program, so sort of hard-coded in. And then I'm going to write a function to do the reversal. So I'm going to call this void reverse string, and it takes as argument some string. Okay, and you can see here that this function doesn't return anything because the goal of the function is going to be to modify the string that you provided. Okay, and so then I'm going to print out the string. I'm going to print out the string before I make a modification. So that would be print out S, and then I call reverse string, and I provide it my string S. And then I'm going to print out again. So print out string after. There we go. I'm going to save and just compile and run that to make sure I haven't made any obvious errors so far. Practice strings 1. Okay, that looks good. Okay, so now what about the reversal itself? I'm not going to go into too much detail about some of the mechanics of this because I'm going to use basically exactly the same logic that I used a couple of videos ago when we were doing exercises on 1D arrays. I'm just going to adjust it to deal with the case of handling a string. So let's do one. Okay, so this is more characters than I need. H-E-L-L-O. And then my string ends with a null terminator. So I guess I can erase this extra box. Okay, so the way I'm going to do this is first, you gave me a string. So the first thing I'm going to do is go and figure out the length of the string. So functionally, the length of the string here is 5. The array is going to have size 6, as we know, because of the null terminator, but the length of the string is 5. This is the only thing I want to modify, the actual characters. So the reversal that I do, I'm going to use the same reversal algorithm that I did in a previous video. It's basically the same as the 1D array case. What I'm going to do is I'm going to keep track of 2 indices, an index on the left and an index on the right. And at each step, I'm going to swap the character referred to by the left index with the character referred to by the right index. So that would go like this. So the O goes here, the H goes here. And then at the end of each step, I move the indices closer together. So the right index moves backwards by 1, and the left index moves forwards by 1. And then I swap again, so then there's the L and there's the E, and then I'm going to move them one more time. And if I ever reach a state where the left index, well, okay, I want this condition to hold. I want to keep going as long as the left index is less than the right index. If I ever reach a state where this condition doesn't hold, then I'm going to stop. And we saw, if you go back a couple of videos, we discussed a bit the various ways I could derive this condition. It turns out that if I don't use this less than sign, I end up with the code not working in certain cases. So the way I'm going to approach this is, I know how to do reversal of 1D arrays. So just an ordinary array. And a string is an ordinary array, it just has this special thing at the end, this null terminator. I don't want to move the null terminator because the string is going to have the same length after I'm done reversing it. So I'm just going to ignore the null terminator and treat the string, once I find out its length, I'm going to treat the string as if it has, in this case, length 5. So my goal is basically get the length of the string and then treat the string just like any other array. Okay, now to do that, I'm going to need the length of the string. And ChatGPT told me that I should be trying to use the library functions if I want things. So although on an exam, it's absolutely fine if you chose to write a loop to compute the length of a string, this seems to tell me that ChatGPT seems to be hinting that I should be trying my best to use the library functions to get string lengths or to concatenate strings or whatever. So I'm going to do that. So int length is equal to strlen of my string. So this is the string length function. All right, so now that I have the length of my string, I can treat it like it is just a 1D array. So I'm going to do the same thing I did in the previous video. So I've got the left index starts at 0 and the right index is the length of the string minus 1, the index of the last actual character in the string. So I will redraw my string quickly just to demonstrate that. So here's my string here. And there's the null terminator, and here are the indices. The length of the string is 5, because there are actually 5 legitimate characters, not counting the null terminator. If I want the index of the last valid character, so the length is 5, if I want the index, that's going to be index 5 minus 1, index 4. That's where I'm getting this from. IDXR is going to start at so IDXL is the first valid index, IDXR is the last valid index. Okay, I guess I'll leave the diagram up for a minute while I continue. And now I'm going to keep iterating as long as IDXL is less than IDXR, because the idea is that that IDXL is on the left of IDXR. And then at each step, I'm going to swap 2 characters. I'm going through this quickly because we already saw this algorithm a couple of videos ago. So I go grab the character of the string at position IDXL, and then into the position of IDXL, I guess I shouldn't use an int, I should use a char because my string is an array of type char. Into the position IDXL, I copy the character over from IDXR. And then I take into IDXR, I install that temporary character, and then I increment IDXL. I move that one forward by 1, and I decrement IDXR. All right. Now, those of you that want to be clever and want to try and find a way of using fewer lines of code, as we now know in this course, there are clever ways of incorporating these incrementations and decrementations directly into some of these statements. Although if we do that, maybe we have to do more testing, maybe we're less confident that our code is going to work. Adding a couple of extra lines in exchange for confidence and the feeling of security of knowing that things work, I think is worth it. And I think that's the code that I need here. I was able to get through this quickly, basically because I'd already written the same algorithm a couple of videos ago. But that doesn't mean that I am free of the burden of having to test it. Okay, so we'll try testing it out on this input. Okay, so it looks like it is reversing. I'm going to do a little spacing trick here, add an extra space so that the two strings get lined up when I print them out. Okay, so it looks like that is reversing. Let's try another string. We'll do hello world with a space in the middle. The space is actually exactly in the middle, so it should end up exactly, it should actually end up not moving. So there we go. For my money, it looks like this is reversing. Now, the exercise said it takes the string as input. And by this stage in the course, we should consider that maybe input actually means that it reads it from the user. Okay, so how can I do that? Well, there are a few ways I could do that. I could use the scanf function. So the scanf function would read a string if I asked it to. We'll cover reading strings of scanf in more detail a little bit later in the course. Scanf reads a single word from the user. I could use this function called fgetS that we probably haven't seen yet by the time you're watching this video, but who knows. FgetS reads an entire line from the user. Or I could maybe just read the string myself. I could read it manually by reading one character at a time. I think I'm going to do that because we'll talk about scanf and fgetS later in the course, and we'll do some exercises on those in a future video. But just in case we don't know those yet, why don't we try and read the string directly from the user using getchar? This will be a good way of practicing that. So what I'll do is I'll make a string s of maximum length. Well, the size of the array is 100, which means the maximum length of a string stored in s is 99 characters, because I must leave space for that null terminator. And now what I'm going to do, I don't need a semicolon at the end of my comment, and now what I'm going to do is I'm going to use getchar to read characters from the user, and then install them in my string. Enter a string. Okay, so I'll ask the user to enter a string, and when they press enter, and press enter when you are done. It's a very cumbersome prompt. All right, so what I'm going to do is I'm going to keep track of where I am inside my string. So we'll call that, we'll just use I as the index there. I started index number 0. And now I'm going to use the getchar function. I'm going to create a character C, and I'm going to call getchar. And I'm just going to read characters until the user enters a new line. And then I'm going to stop. So while C is not equal to a new line, what do I want to do? I want to take the character that they provided, and I want to add that as the next character in my string. So I'll just set S sub I to be C, and then I'll move I along by 1. And I guess I have to add a secondary condition, which is that the string can only store 99 characters. If they enter more than 99 characters, I do not want to walk past the end of the string. It is my responsibility as a programmer to make sure that no matter how oblivious the user is, that they don't end up running past the end of my array. Even if I tell them don't enter more than 99 characters, sometimes the user doesn't read your directions. So I'm going to add a second condition here, which is if I get to index, I have to make sure I is less than 99, because I'm going to need index 99 at worst, because that's the latest possible place I can put the null terminator, because the array has size 100, so the last index is 99. I need to make sure that I doesn't equal 99, so that I'll always have some space at the end of my loop to add a null terminator to my string. Okay, so this extra condition helps me with that. It'll just quit the loop immediately if we get past 99 characters. And I just realized I'm missing one of the ingredients of my loop. So if I want to keep reading characters, I have to call getchar again at the end of each iteration. Now, when I print the strings out, I'm going to put them inside of square brackets, so that way, no matter what I type in, it's obvious what it was able to pick up and what it wasn't. So I'm going to try testing this. I'm actually not entirely confident this is perfect yet. I just figure I might as well test it, and if it crashes, that's a sign that it's not perfect. We'll see what happens. Enter a string and press enter. So I'll enter hello and press enter. Before, the string is hello. After, it got reversed correctly. Okay, we'll try hello world. Looks like it read the string correctly. Okay, that's a good sign. Let's try entering nothing. Okay, the string is empty. That's why I put those square brackets there to make it clear that there's nothing inside the brackets. We'll just try entering a bunch of spaces. Okay, that works too. And now I'll just enter a large amount of material, okay, to make sure that it works on a relatively long string. I could test the case where there are more than 99 characters. I guess we could try that out. So let's see, how am I going to do this? What I'm going to do is I'm going to type out something. Okay, here's a 5-character string. I'm just going to copy and paste that. Now it's a 10-character string. I'm going to copy and paste this 10 times. Oh, actually, I'm going to start again. Okay, I have it one time. I'm going to paste it 9 more times. 1, 2, 3, 4, 5, 6, 7, 8, 9. I believe this is a 100-character string. Okay, so it looks like I'm going to take my own word for it and say this is 100 characters. Down in Jupyter Hub, it shows me that I'm on column number 101 when my cursor is here. So that is one way of reinforcing that I have gotten 100 characters. Okay, I'm going to paste my 100 character string in and press enter and see what happens. And because it's 100 characters, I know I can only read 99 of them before my string runs out of space because I need 1 character for my null terminator. That means I expect the string to get cut off at this. So that last O should get cut off. And when I look at my test, I notice that yes, it turns out it is. That last O got cut off. Now, just in case that was a fluke, we'll try it again. So I'm going to paste this thing in, and then, I tried pasting, it did not work. Okay, there we go. And then I'll put a bunch of garbage afterwards. So this string is way longer than 100 characters. But notice how even so, it does stop after 99 of them. Okay, so that provides me at least some context to justify that my code is correctly reading only up to this limit that I've defined, this 99 character limit. All right. Now, an improvement that I might suggest for later is I might want to use a named constant for the size of my array. And in this example, unlike in our 2D array examples, I could just use a constant variable. So I could say const string size or string max is 100. And then I could use this constant, const int. I could use this constant to create the string, and I could use it again down here, so string max -1, as a way of allowing myself a bit more flexibility, a bit more modularity, if later I want to change the maximum size of the string. So we'll just compile that to prove that it works, and then I'll try it on a couple of examples. So it works on hello, it works on hello world. I put a space at the beginning of hello world this time. You can see there's the space there. All right, so I think that's working. And I think I might need this loop again in a few minutes, so maybe that's helpful. All right, I think that's the end of exercise 1. So we'll go back over and take a look at exercise 2. Write a program that checks if a given string is a palindrome. A palindrome is a string that reads the same forwards and backwards. And so the word race car is an example. I think the word level is an example. Okay, so and the word radar is an example of a palindrome. Okay, maybe you get the idea. You probably have seen palindromes elsewhere by now. Okay, a palindrome is a piece of text that reads the same forwards and backwards. This particular palindrome exercise has a bit of a twist, though. It's suggesting that I also evaluate whether something is a palindrome even if it contains spaces. I just ignore all the spaces. And even if it contains capital letters, I just ignore those. And even punctuation. So I'm going to solve this in 2 stages. I'm going to start by writing I'm going to start by trying to solve it the basic way of just, is this a palindrome, yes or no? Then I'm going to try and adapt it for the case where I'm finding palindromes of much more complicated things. Okay, so I'm going to copy my exercise over. I'm going to go to a new file here. There we go. And I suggest you try this exercise out as well. Even if you're a bit nervous about this last bit, see if you can get to the end of this point. Because up to the end of this point, with being able to detect palindromes like race car, that is a very sort of standard issue 111 exercise. That could show up. An exercise of that strength could easily show up on an exam in this course. All right, so I'm going to begin, write a program that checks if a given string is a palindrome. It says given string, so I think this time I'm just going to use a hard-coded string, so I'll call it S again. And I'll start with a string race car. And I'm going to print out the string once. I'm going to say the string, I'll put the string in square brackets, is, actually, maybe what I'll do is this. I'll create 2 print statements, so one that says it is a palindrome, and then I'll just create a second print statement that says it is not a palindrome, and then stick them in if statements. So I'm going to write, I think I'm already beginning to see what I'm going to do here. So I'm going to make a function called isPalindrome that returns true or false. And if it returns true, then the string is a palindrome. And if it returns false, then the string isn't a palindrome. So we'll say is not a palindrome. All right, and then I guess all that remains to be done is I have to write this function isPalindrome. So I'm going to create the function signature, and then I just want to do a quick test before I go further. So isPalindrome, it takes a string as its argument. There we go. For now, I'm just going to have it always return 0, and just as a way of verifying that main is working correctly. So I'll clear this out. I'm going to go and compile my new file, which is practicestrings2. Okay, and it's got a couple of complaints for me, and I think both are legit. So I'm trying to print a string with %s, and then I never give it a string. So that's a fair, I mean, I can see why the compiler would be a bit nervous about that. So we'll try that one again. Looks like it compiled this time, so we'll try running it. Okay, the string race car is not a palindrome. Okay, that makes sense because currently I'm returning 0 in all cases. Okay, so how do I decide if a string is a palindrome? Now, really, this actually comes down to the same logic as reversing the string. So if I have the ability to reverse a string, then I can decide if the string is a palindrome or not. And what I mean by that is if I have the string, so let's use the string hello again. There it is. And suppose that I am able to get a hold of its reversal. So there's the null terminator. So the reversal of the string hello is OELLH. If I have the string and the reversal of the string together, all I have to do is compare to see whether the string and the reversed string equal each other. That's it. I just loop over them and compare each character together. Or alternatively, I could use the string compare function. Now, although the spirit of the day seems to be using library functions, I think I'll start by writing a loop to do this manually because I suspect that not everybody likes using the string compare function as is. So my logic here is if I can come up with the reversal of my string, then it should be pretty easy to solve this problem, to ask whether or not the string is a palindrome. And, you know, what do you know? It turns out that like 5 minutes ago, I literally wrote code to compute the reversal of a string. The issue is the code that I wrote reverses the string in place. What I want is to create a copy of the string containing the reversal. But whatever, let's just copy our function. We'll just use the reverse string function that I already wrote. I could also write a brand new reverse string function that creates a copy, but whatever, I've got the code, I might as well use it. So what I need is to create a copy of this string and then reverse that. And that shouldn't be too difficult. I think I can do that. So what I do is I'm going to make a new string. I'm going to first get the length of my current string. I guess I have to include string.h. So there's string.h. I'm going to get the length of my string. So I go grab the length using string length of the string that was provided. And now I make a new string. So you gave me this string hello. I'm just going to keep drawing the string hello over and over again. Okay, so you gave me this string here. And so what I'm going to do is I first figure out the length of the string. So this string has length 5. I'm going to make up a new array big enough to store another string of length 5. But of course, remember that I need space for that null terminator, so I have to add 1 to that length. So the length of hello of this string hello is 5, but the length of array I need is 6. So I'm going to call this reversed, and then I make it len plus 1. Now this is critical. So what I've done here is the new string that I create, the length of that array is determined by the string you provided. I don't want to just make a string of length 100 or something, because what if you provided a string that was too long? I want the function to work in pretty much every case. Unless, of course, the string you provide me is so long that the computer runs out of memory. That's not really my fault. There's nothing I can do about that. Okay, so now I've got this string called reversed, so that's this. And the way I'm going to do this, I want to use my function that I created a minute ago. So the way I'm going to do this is I'm going to copy fully copy the string hello into my reversed string. And then I'm going to take this whole string and hand it over to my function. And the function should then reverse that string in place, which is a lot of steps, I mean, to be sure, but I think I'm saving work because I don't have to rewrite my reversal code. I'm leveraging code I've already written. Okay, so the first thing I do is I copy, using the string copy function, I copy into the string reversed the contents of the string str. And I can be confident that the copy should work because the string reversed does have enough space because I designed it to have enough space to store the thing I'm copying. Okay, and then I call my reverse string function. I call reverse string on this. And this actually produces the reversed copy of the string. And you know what? Before I continue, I'm just going to test out what I've just done. I'm going to clear this so that way I can redraw my... Actually, maybe I'll just erase the parts that are overlapping the code, because I'm going to need this diagram again in a minute, almost certainly. Okay, so str equals this. I'm just going to quickly print some stuff out to verify that I haven't made a big mistake. Reversed equals this. There we go. And for the sake of testing, I guess I should test this on a string that isn't a palindrome because it'll be harder to tell if I'm doing the reversal correctly otherwise. Okay, so we'll try compiling this. Now, the function's going to return 0 because I haven't written the rest of the function yet. So it's going to print that the string is not a palindrome. That's not what I care about. What I care about is that it prints hello world when it prints this line, and it prints the reversed version of hello world when it prints on line 37. Okay, so let's see. Okay, I made a mistake, but str is hello world, and then it prints out the reversed string, and it's not reversed. And this is the kind of bug that, depending on the day, I might either fix instantly or spend 4 hours staring at. The problem is I forgot what I was doing, and I forgot to actually give printf the string I wanted to print out. I'm printing out the string reversed, so I should be giving it that string. So we'll try that again. Okay, and it looks like it is printing the reversal of the string. I'm not going to test this too much further because the reverse string function I already tested a few minutes ago, so I'm reasonably confident that it works. And it seems like the sequence of function calls I made was sufficient to get the reversed copy of the string. Okay, so now what I'm going to do is loop over str, reversed, and compare characters. If any characters are different, or, maybe I'll be more precise. If stri is not equal to reversed I for any index I, then then str is not a palindrome. And then otherwise, if we don't find a case where the characters don't match up, then otherwise str is a palindrome. I think that's my logic. So I've written myself a comment to explain what I'm about to do so that if I get distracted again, I will be able to do it. And I guess I just need a loop. And the question then is, how long does the loop iterate? Well, I know the length of the string. And since I already know it, I could write a different style of loop that goes searching for the null terminator, but I already know the length. I'll just write a for loop that uses indexing. So I is equal to 0, I is less than length, I plus plus. Because I do have two strings I'm working with, but they both have the same length, so it shouldn't be a big deal to just use use this one index variable. At each step, I'm going to ask if string sub I is not equal to reversed sub I, then I guess we're done. Because if this condition holds for any index, then the string is not a palindrome. In other words, I already know the answer to the question the function is supposed to answer. It is no in that case. So I'm going to return instantly. And as I mentioned in an earlier video, I like returning early in cases like this. You don't have to do it that way, but I like doing it that way. So on line 42, I'm just going to say return 0. If I find one piece of evidence that I don't have a palindrome, I'm immediately done. Otherwise, if I get down to line 45 and I haven't found evidence that I'm not looking at a palindrome, then by default, it is a palindrome. So then I'll return 1 for true. Okay, I'm ready to test this out. Okay, so it prints that hello world is not a palindrome. Okay, that shouldn't surprise me. It obviously isn't. And then what about the word race car? Is that a palindrome? I have to compile it again. That is a palindrome. Okay, that's a good sign. Let's try some other palindromes. Level. The word level. Is that a palindrome? Looks like it is. What about levels? So I'm going to add something to confuse it a bit to make sure that it's not, these aren't false positives. It's not a palindrome. Okay, now what about this one? So there was that suggestion ChatGPT gave me, a man, a plan, a canal, Panama. Panama's Okay. Now, this is not a palindrome. This string, as it is not a palindrome because the A at the end isn't the same character as the A at the beginning. We actually aren't done the exercise because we have to go and handle that case. Notice how I first solved the basic case. I wrote some code to handle basically the idea of what is a palindrome in a general sense. Now I'm going to broaden what the code does to handle this much more complicated situation of ignoring spacing and ignoring capitalization. Okay, so I'm going to let's try running it again. This is not a palindrome. But if I remove the spaces myself, so if I go through here and I remove the spaces and punctuation and capitalization myself, this is, or it should be, a palindrome. We'll see if the code agrees with me. Okay, this is a palindrome. Maybe you can see where it's going. So or maybe you can see where I'm going with this. So the string that it gave me, that ChatGPT gave me as an example, that is not inherently a palindrome by the most strict definition. But if I manipulate it a little bit, if I get rid of the spaces, if I get rid of the capitalization, so I convert everything to lowercase or everything to uppercase, and I get rid of any punctuation that's present, then it is a palindrome. I want a program that can take a string like this and say, yes, deep down this is a palindrome if I ignore those things. So how am I going to do that? So one thing I have to observe is my program should be allowed to take this kind of a string as its input. So that, like a string full of spaces, full of capitalization, full of punctuation. My goal is I have this function that I think works pretty well that will decide if something literally is a palindrome or not, based only on the characters in it, not worrying about capitalization or anything else. What I need to do is convert the string you gave me into that format I had from earlier where all everything was lowercase, there were no spaces, there was no punctuation. And here's where I have to go and ask ChatGPT for a clarification. Oh, that's disgusting. There we go. So it says ignore spaces, punctuation, and capitalization. Okay, I know what a space is. And if I don't know what a space is, one thing I should use is probably the isSpace function. That's a good way of deciding whether a character is a space. I also know how to handle capitalization. I could convert every character to lowercase. But punctuation is ill-defined. It's not clear what punctuation means, so I'm going to ask it to clarify that. In exercise 3, what characters are considered punctuation? Okay, it doesn't... whatever. So it looks like it misunderstood what I was asking, I guess. In the context of this exercise, when considering punctuation, you generally want to ignore them. Yes. Punctuation marks okay, the best I think it's going to do is tell me that they include characters like commas, periods, exclamation. Okay, that's weird. So this isn't a very good specification. This is just giving examples. I want an exhaustive list of what should I ignore, what shouldn't I ignore. Not, oh, ignore things like commas, periods, exclamation points, question marks. Yeah, but what about like the @ symbol or the hash symbol or something? This isn't clear, although I sort of see where it's going. Maybe what it means is I should ignore every character that isn't a letter. So I'm going to ask it if that's a valid interpretation. Am I correct if I interpret the exercise to say that I should ignore any character that isn't a letter, e.g. spaces, punctuation, etc.? That's certainly going to make my life easier if it allows me to do that. Okay, so it's now saying, yes, I'm correct. It's saying a whole bunch of other stuff. I don't really know if I have the patience to read through it. Yes, in the context of string palindrome check, the idea is to consider only alphanumeric characters, okay, whatever, fine, letters and digits, and ignore any non-letter characters. Okay, so I'm actually going to go back over and change the written version of the exercise to say this. The reason why the clarification was important isn't that I have a problem ignoring punctuation. So the way it was originally written, there's nothing really wrong with this except that it doesn't tell me what it means by punctuation. And in the context of a formal specification, that's really important. If the person writing the specification, or, you know, the weird AI thing writing it in this case, and I have a different idea of what punctuation means, it will affect whether the result is considered correct. Capitalization, though, I understand. So I'm going to rewrite the exercise based on this last clarification. Ignore any non-letter characters. I'll just copy that in case I can insert it directly over here. So yeah, ignore any non-letter characters and capitalization. I'll just paste that in. Ignore any non-letter characters, including spaces, punctuation, and other symbols, and capitalization when checking. Okay, so the way I interpret this step, or the way I'm going to implement it is, I've written my reverse string function, it works. I've written my isPalindrome function, and if you give it a string and ask, is this string literally a palindrome, it gives a good answer. I don't want to modify this function now that it's working correctly. I'm going to add an extra step, so I'm going to say, create a new string that contains all of the characters in S except non-letter characters, or ChatGPT did say alphanumeric characters, so letters and digits. So I guess, okay, so I'm going to rewrite that with that contains only the letter and digit characters in S, where all letters have been converted to lowercase. So the way that the exercise was phrased, it says that this word here, race car, is a palindrome, and it is literally a palindrome. Like, without any modification, we can see it's a palindrome. But the exercise appears to say that capitalization should be ignored. So this term here, which is also the word race car, is also a palindrome. And the way that I'm going to handle that is I'm just going to convert everything to lowercase, because once this is converted to lowercase, it's clear that it is a palindrome. Okay, I'm going to create that new string. There are a couple of ways I could do this. I could write a function to do it, and maybe in the context of a larger exercise, that's what I should do. But I don't know what to call the function, and I'm going to play around with it. So I'm going to start by doing it in main. So I'm going to call this, I don't want to call it new S. I'm going to call it, it's been cleaned up a bit. Let's see, I'm going to say, no, maybe we'll just call it new. I don't have any good ideas for a variable name. New S. I need to create a new string that can store up to this many characters. The string that I create might have a shorter length than my original string because I'm going to omit a lot of stuff, but it will certainly never have a longer length. So I need to make a string that's big enough. So to do that, I've got a couple of options. If I want to be really fastidious, I could go through and count how many letter or digit characters there are, but I don't want to be that fastidious. So I'm just going to make a variable. I'm going to figure out the length of S by calling the string length function, and I'm going to make new S big enough to hold all of those characters. So again, I do +1 because I also want space for the null terminator. Because in the case where this was entirely letter or digit characters, I would need enough space for a full copy of my string. Okay, so I'm going to now make an index variable, and my idea is basically if I have my string, so let's just draw the same diagram I've already drawn a million times. So actually we'll do this, LLO. So here's suppose my original string was this. There's a hastily pasted on null terminator. What I'm going to do is make my new string and just bring in all of the characters that are letters or digits and ignore everything else. So I'll have two indices, one for the string I'm copying from, one from the string I'm copying to. At each step, I'll use a loop. At each step, I will copy the character if it's a letter, and if I perform a copy, I'll move ahead the index in the new string, and then I'll move ahead the index in the old string. So I copy this letter, I move both indices ahead by one, but here I'm at a space. If I see a space, I just move ahead the index for the old string. And maybe you can see now why I have to have two index variables, because they could be positioned differently in the new string and the old string. I copy the letter L, I then move both of them along by one. I copy the letter L again, I move both of them along by one. I copy the letter O, and I move both of them along by one. When I hit the null terminator, I just copy in the null terminator, and as you can see, my new string is now a complete and valid string. So I guess what I'll need for that is two index variables, int old index, which is equal to 0, int new index, which is also equal to 0 to start with. Okay, and now I'm going to keep iterating as long as I haven't hit the null terminator in the old string. So I'll write a while loop for this, while s at old idx is not equal to the null terminator. Okay, and then I ask the question, what I want to do is copy the character if it is either a letter or a digit. So in that case, I can test if something is a letter by using isAlpha. So I'm going to have to include ctype.h for that facility. There we go. So I've brought in ctype.h. If isAlpha, s at this, so I go grab that index of s. If it is a letter, or using logical or, if it is a digit, s at old idx, then I can copy the character. But I don't want to copy it just yet. I actually missed a step. I missed something in my example that I just did. When I copy a character, I want to also convert it to lowercase. So that what I end up with is this sort of canonical form of the string. It's going to be entirely lowercase with all the spaces and extraneous stuff stripped out, which means my isPalindrome function can work just like it was working before. Okay, so what I'm going to do is convert this character s at old index to lowercase and then copy it over. I'm going to do that in one assignment statement. So new s at index new idx equals toLower of the character that I'm taking. Recall that the toLower function doesn't do anything. It returns the character intact if it's already lowercase or if it's not a letter. But if this character was an uppercase letter, it would get returned as its lowercase version. Okay, now anytime I copy something into my new string, I increment the index. And regardless, so at every iteration when I'm working with my old string, I always increment the index. So you'll notice that this incrementation is outside the if statement, because whether or not I copy the character, I want to keep making progress iterating through my old string. Anticipating that maybe there are bugs in what I just did, actually I already see one, which is that when I'm done my loop, I was supposed to be creating this new string, but I never added a null terminator. So I'm going to do that now. So new s at the current index equals the null terminator. And the logic I'm using here is that at the last step, so I've got something like this. At the last step, new idx will be pointing to this position, and old idx will be pointing at the null terminator in the old string, because that meant the loop ended. So the loop ends, and I know then that new idx will always be pointing at exactly the right position to put my null terminator. So that's why I'm putting it at position new idx. Okay, before I go forward, I'm going to print out new s is, I'm going to print it out to make sure that it does match what I'm expecting. And then I'll print out new s. Okay, and then when I test whether it's a palindrome, I'm going to base my test only on the new version of the string with all of the extra, the spaces and punctuation stripped out. So we'll try that. Okay, so the original string was this, a man, a plan, a canal, Panama. And if we look at what new s was, what we get for new s, it is what I expect. I've got all the same characters as there's a man, a plan, a canal, Panama, and all the punctuation and spaces are gone, and all the letters have been converted to lowercase. Okay, so I don't know, it looks as if my program is working. I'm going to comment this out, and then I have to test. So the problem with a program like this, where you're searching for something complicated, whether something is a palindrome or not, I think is that people tend to have a bias when they're testing on things like this to want to test things that are palindromes. We have to make sure we also test a bunch of stuff that isn't a palindrome. So let's just make this thing, like not a palindrome. Okay, there, and it's no longer a palindrome. Let's make sure that we get the answer no for that. I've seen a lot of cases where people write programs that are supposed to give yes or no answers, and it always gives the yes answer. And they think it's correct because they've only ever tested it on cases where the answer is yes. We need to make sure it can say no as well. Okay, so there's that. Let's see what happens if I make one word all uppercase. Okay, that's still working. Okay, so let's make this lowercase again. Now let's see, I'm going to add some synthetic changes. Let's add some digits. So this is still a palindrome as long as the same digits appear at both ends of the string. Okay, that is a palindrome. Now what if I break it? What if I remove some of the digits but not all of them? And I have to test this because what if it turns out it's throwing the digits away and not considering them? I need to make sure that it is still able to recognize that it isn't a palindrome if there are digits present. And it looks like it can. That looks pretty good. Now for more advice, I'm actually going to ask ChatGPT to help me a bit here. Can you give a few test inputs for exercise, what was that? It was the original exercise 3, I think. Yes. All right, here are a few tests. Okay, good. And it looks like it's going to give me a mixture. All right, so race car is a palindrome. Man, a plan, canal is a palindrome. The word hello, we already tested that, is not a palindrome. Oh, here's an interesting one. Was it a car or a cat I saw? Okay, this is neat because it's got some punctuation in it. So we'll go try this one out. So the answer to this one should be yes, it is a palindrome. And the answer is yes. Let's make sure that's not a fluke. Let's just add some junk to it to make sure that it doesn't work if I add the junk. And now the answer is no. That's a good sign. Let's try some more tests. Okay, no lemon, no melon. Well, that's a fair, I try and live by that adage. We'll try this one out. So we'll put this here. That's a palindrome if we ignore the capitalization and remove all the spaces and commas. I would never have thought of that myself. Okay, that is a palindrome. Okay, so let's see. Let's just break this somehow. Yep, not a palindrome anymore. Okay, we'll head over into, okay, coding is fun. Well, that's true, but it isn't a palindrome, but we'll make sure the program thinks so as well. Okay, it's not a palindrome. That sounds good. What else can we test? Okay, so here is a palindrome entirely made out of digits. These are some good test cases. I wouldn't have thought about this one where I test the answer being yes on only digits. Now, some of this is a bit overkill, I think, for just a quick exercise. If this were an assignment question, you would want to do this because, well, a couple of things. One, when I design the test cases for assignments, I do try to be thorough. And two, to be honest, at this rate, I might as well ask ChatGPT to help me generate test cases for assignments because it looks like this is one of its strengths. Okay, so this is a palindrome as I expect it to be. All right, so what else do we have? The word palindrome is not a palindrome. It's a sort of weird meta case. I don't think we need to test this. We already tested it on a few examples of lowercase and uppercase letters. And then it's beginning to run out of ideas on its own. I don't think I'm going to try it on this one. I sort of know, I think that's enough testing of just the digit case. This is sort of weird, but fair enough. We might as well try it. This is supposed to be a palindrome. So we'll try testing this. We'll save the file. There we go. Okay, that is a palindrome. And I think we could probably ask ChatGPT for even more test cases, but I think this is a good number. And I think between all of these, I've covered a lot of cases. I've got punctuation, I've got capital letters, I've got digits. And so I can be pretty confident that I now have code that implements this pretty non-trivial exercise to test whether something is a palindrome, even subject to ignoring capitalization, spaces, and punctuation. But we're not done yet. We still have one more exercise left, and it's going to be a tough one. It's going to be more complicated than that last one, and that last one was pretty high level. That last one was almost at assignment level difficulty. So let's take a look at the exercise that ChatGPT suggested. So it's way up here. It suggested exercise number 4. Anagram grouping. An anagram is a word or phrase formed by rearranging the letters of another. Okay, we already saw this. So for example, the two words listen and silent, those are anagrams. Again, hit and if, those are anagrams. If must mean something, I guess. And then hello and world are not anagrams of any of these other things. So let's see. I'm actually going to ask it for another. Can you give a more detailed, maybe a longer input example for exercise 4. And then because it always wants to do this, I'm going to tell it, do not show me the solution to the exercise. All right, so here's the input. So suppose the user enters this incredibly long list of words. Listen, silent, hello, world, hit, if, reliant, tack, and cat, which due to the strange way ChatGPT chooses to format this word list, this word is a name of basically a programming language. These two words are significant in that language. Earth and heart. Okay, so earth and heart are anagrams of each other. The word apple and elpa are anagrams of each other. Okay, it doesn't show me the output for this though. So can you show me the output for the example you just gave? I'm going to remind it just one more time. Don't show me the solution don't show me, I guess maybe it didn't show me the solution. When I said didn't show me the solution, it might have interpreted to me the output. Don't show me the code for the solution. Certainly. Okay, so if I enter this set of input, then it should create these groups. So you can see how among all the words I entered, it finds a way of grouping them together into groups where everything inside of a group is an anagram of everything else. But this isn't, I don't think this is a good test case. This isn't what I really wanted. I want to see a case where a group has more than, that has more than 2 things in it. Can you generate another test input where some groups of anagrams have at least 3 words in them? Oh, I forgot to say don't show me the solution. Okay, so here's a really long example. can you show me the expected output for that input? Don't show me the code for the solution. I can always ignore the code it shows me, but I don't want this to be spoiled. I want to have to tackle this from scratch. Okay, so we enter this long list of words. We enter stop, tops, and post. And we then enter later listen and silent. And in my interpretation, it doesn't matter if I enter the word post way down here. When it's done reading the entire list of words, then it groups them together. We can see here, stop, tops, and post are all in the same group. And then I've got listen and silent. I've got dear, dare, and read or read. Apple and pleep, whatever pleep means. I guess I could ask it about that. I'm learning some really interesting vocabulary today. And then care, race and acre, earth and heart, night and thing. Yeah, that checks out. Weird. Glisten. Okay, and then ChatGPT begins to make a bit of a mess of things. Glisten and inlets are not anagrams of each other. Inlets, I think, is an anagram of listen. Astronomer and moon starer. I really want that to be true. That would be great. Okay, but reliant and restrain? Absolutely not. Gathers and hamburgers? Absolutely not. So as usual, ChatGPT is not really ChatGPT is very good at sounding smart. Sometimes it drops the ball, especially, it seems like whenever data is involved, ChatGPT can just invent things and not understand them. I think, though, it's given us enough to work with that we can do this exercise. Now, I've got to do a couple of things to simplify the exercise, because the way I would normally solve this is using techniques from, I think, week 10 or week 11, something called structured data, and that would make my life a lot easier. I might even want to use something called a linked list, which is something that we'll see in week 12. Because I don't know about any of that stuff yet, and I don't know about dynamic memory allocation, I'm going to have to find a way of solving this using only what I already know, which is arrays and strings. And so I'm going to have to make a couple of simplifications and also do a couple of things that are a bit weird looking from your perspective if you're looking at this in week number 8 or week number 9. Okay, but I think I have the general idea. The other thing I'm going to do is I'm going to use the scanf function, I think, to read the words. And I'm going to start there. That's how I'm going to begin this exercise. I guess I also have to actually paste in the exercise. So we'll go up here, anagram grouping. All right, I'm actually going to paste the entire example just so that I have that as a point of reference. Okay, there we go. That somehow pasted something else. It pasted like everything I'd said to ChatGPT. So I'm going to go back over. I'm not sure why, but like my copy function's not working very well today. Did that copy? It's an odd place for there to be dead air in the video. Okay, so I'm just going to copy the text of the exercise. I don't think this is ChatGPT's fault, although I'm not going to take the blame for it either. I'm going to say it's maybe like my browser's fault. So there we go. We've got that. And now I'll go back over and hit the special copy button, which I assume works properly, to copy the example. Okay, so there's the, this is like example output. Okay, so the first thing I'm going to do, this is a project. This piece of code is probably going to be very expansive. I may actually have to go back and refactor it a couple of times to clean it up a bit because it's going to take quite a while to write. So the first thing I'm going to do, the problem with programs like this is that it's really easy to stare at them and basically just stare into space. There's so many things you have to worry about that it's hard to know where to get a foothold. How do you start climbing this hill? So when I think about this, I realize first, if I write any code at all, I'm going to need to test it. I will not be able to write this whole program before I test it. I have to test things as I go. Then the question is, what is the best way to bootstrap myself into something I can test? So what could I write that I could test easily that does some part of this? Well, I have to read a list of words from the user. Okay, so maybe I'll start with that. Let's see if I can read one word from the user. And here is where I'm going to make two simplifications. The first one is I'm going to define a maximum word length. So my word length is going to be, I don't know, I can't imagine a word being any longer than 50. Okay, so that's my maximum word length. Okay, and then I'm going to define a maximum number of words that I'm going to read. So max words equals, let's do again 50 words. So I could always change this to allow myself to read more words, but without some techniques we don't have yet, I am going to have to set a limit on the number of words I read. Okay, so now the first thing I'm going to do is test out that I can read one one word from the user. So I'm going to make an array called word of length word length plus 1. If I want to read words of up to length 50, I'm going to need an alternator in there. So I'm going to do word length plus 1. And actually now I'm realizing there's a little bit of a, there's going to be, I'm going to have something else I have to simplify in a minute. So first thing, can I read just one word? Okay, so enter one word. I'm going to use scanf for this. And depending on when you watch this, maybe we haven't covered how to use scanf with words yet, but we're going to do it soon, so I'm just going to jump right in. If I wanted to read words manually with getchar, I could just go back and steal the stuff I was doing in exercise 1, like an hour ago. But I'm not going to do that. I think I am going to just try using scanf for this. You know, that's a difficult... Yeah, no, I'm going to use scanf for this. Okay, so to use scanf for this, what I want to do is something sort of like this. I use %s to say read me a string. Scanf by default, when you use %s, tries to read one word. It skips over white space. Then what I do is I give it the string to put the result. Now, the issue is this is not a correct use of scanf in this course, because if I do it this way, the %s doesn't tell scanf how many characters I'm allowed to read. The word has a maximum capacity. I have to tell it how many characters it can store inside the word and still have space for a null terminator. So I have to write this, and I've put myself in a bit of a corner here. So there is no easy way of incorporating my word length constant. So I'm just going to call that a universal constant and say we will assume that words may have no more than 50 characters. Okay, so we're just going to assume that absolutely. I won't make a variable for it or a constant variable, because if I do that, then maybe you'll think later you could change that and it would fix everything. But I have this 50 sort of hard-coded into this. Now, the other thing I want to do is make it so that when we're done entering words, I've got some way of bailing out. So I'm going to say if scanf of the, well, how do we do this? Let's just start by seeing if we can read one word. Okay, so you entered... So one other observation I'll make, and we'll see this again when we come back to using scanf for other things, is that here, when I pass word into scanf, notice how I don't use an ampersand. I actually could if I wanted to, but I don't need to, because remember that when I use the name of an array, so if I think about this array word that I've created here, so there's the array, whenever I use the name of an array, I am using a pointer already. We know that we have to provide, as arguments to scanf, we have to provide it pointers, but the name of the array is already a pointer, so I don't have to use an ampersand to create a new pointer there, and that's why I'm not doing that. Let's see if this program runs. Okay, so it's complaining about an unused constant. That's not a big deal. I haven't gotten that far yet. Enter one word. Okay, I'll enter the word hello. And it says, you entered hello. Okay, so just to be clear, if I enter hello world, it reads one word at a time. And so when I ask it for the first word, it just reads the word hello and then it stops. Scanf will automatically skip over any of the white space encountered between words. So now the question is, how do I read a list of words from the user? I'm going to start by seeing if I can just read a bunch of words, and then I'll figure out how to store them. So now I'm going to say enter some words, enter up to this number of words, and end the list with the word done. So here's my idea. I'm going to have the user enter a bunch of words and then the word done when they're done. And I'll be able to tell when they're done because I'll read a word and it'll be the word done. Okay, so let's see. I guess to do that, what we'll do is we'll say while scanf is able to read something. So remember that scanf returns the number of items it was able to read, so it makes sense to just use this while scanf is equal to 1 directive here because I'm reading a string. And so what I'll do is I'll just read all the words and then print them out. Now there is an issue of what happens if I enter the word done. I haven't handled that yet. I'm going to add that code in a minute. We'll just see if this works. Okay, so we'll compile, we'll try running it. It's complaining about a bunch of stuff. Okay, yeah, so I said enter up to %s words. This was intended to be the number of words, so that should be %d. And then moreover, I should actually give it something. So I'll print out max words. Okay, that's fair enough. That was my fault. All right, enter up to 50 words and end the list with the word done. Hello world, a bunch of extra spaces, ASDF, whatever, another bunch of junk. And you can see it's able to pick out each of the words and skip over the spaces. But what you'll observe is that it keeps waiting for more words because I haven't given it any way of bailing out. If I hit Control-C to kill the program, it ends, but that's not what I want. I want there to be some graceful way for the loop to end. I guess we could conceptualize that as, okay, we're done. I want to get to this print statement. I don't want the program to end prematurely by me terminating it. So what I'll do is I'll say, okay, while scanf was able to read a word and while the word wasn't the word done. And here I'm going to use the string compare function. So the string compare function takes two strings. I'm going to compare the contents of my variable word with the string done. And the string compare function strangely returns 0 if the words are equal and some other value if they aren't. And that's because string compare isn't designed just for equality comparisons. It's also used for other things. So if string compare returns 0, then the word was equal to the word done. So I'm going to say, well, keep going while this is not equal to 0. Now, if you don't like this, if you think that the use of string compare is confusing and weird, you could always write your own function called strings equal, which is a pretty classic midterm question as well. So if you take two strings, s1 and char s2, and you can return 1 if they are equal and 0 if they are not equal. You could also use that in this case, but I'm going to use string compare. I'm actually quickly regretting that decision to use string compare because it feels like this could be the straw that broke the camel's back, but I'm already doing it. Okay, so string compare returns 0 if the two things you give it are equal. And so if this returns, as long as this is not equal to 0, I haven't typed in the word done. And if you don't believe me, well, let's see whether I believe me. I'm going to try running this. Oh, it's complaining. It's saying you need to include string.h. So these are both pretty cryptic, but you can see this note just says add the line include string.h. So that's fair. I need to do that. So, okay, include string.h. All right. Okay, so we'll do that. And we'll try running it again. Okay, it looks like that worked. Enter up to 50 words, end the list with the word done. Hello world, ASDF, done. And we can see it prints hello, then world, then ASDF, and then it stops. It says, okay, we're done. It doesn't catch the word done by itself because the loop condition fails. This test comes out to be false, and so the loop immediately ends. We'll try it again with a different number of words. Hello, and then, I don't know, a bunch of junk, and then the word done. And we can see apparently it picked up all the junk, including this last piece of junk, which was larger than the other pieces of junk, and then it says we're done. All right, so I think I have a way of reading a list of words. Okay, but that isn't actually the hard part. The hard part is everything after this, but the first hard part is how do I store a list of words? I mean, what do I do? Well, how would I store a list of numbers? If you entered a bunch of numbers, how would I store them? Well, I'd store them in an array. Okay, so I guess what I want is an array of strings. But that's sort of weird because the string itself is already an array. Okay, so I guess what I need is an array of strings would be an array of these things. Or, in other words, I need a 2D array of type char. All right, let's give that a try. So I'm going to call this array all words. All words. And it's going to be a 2D array of, I guess, up to max words total entries, where each element is a string, which would be of length 50 plus 1. So 50 characters plus a null terminator. And now, as I read into my big list, so this is a challenging exercise for so many reasons. I'm going to do it because I'm a completionist. If you've lost the exercise by now, I don't blame you. There's a lot of stuff flying around. If you try this exercise and you get stuck, I don't know that I blame you for that either. If you try it in December, you may want to soldier through it. But in mid-November, there's a lot of things happening. If you are stuck and you want some context, one thing you might consider doing is, before trying to write this, see if you can write a program that reads a list of integers and stores them into an integer array, not an array of strings, because arrays of strings are pretty weird. Okay, so I'm going to make my array all words, and then I'm going to make an index of the number of words that I'm keeping so far. So currently num words equals 0. And I guess my logic is I've got this 2D array of type char can be thought of an array of strings. There's one word, there's another. What I'm going to do is I'm going to keep track of how many words do I already have. So at the beginning, I've got 0 words. So in my bank of strings, I have nothing. And I've got this variable called numWords, and it's going to contain the current number of words that are stored, which conveniently will also be the index of the next place to put a word. So after I put the word hello, there is 1 word stored, but that also happens to be the index of the place I put the next one. So that's the logic I'm going to use. Okay, so now what I do is, once I get a word, if I'm reading words from the user, what I can do is I can copy them into my big array. So the idea behind this string array is that element all words I contains the ith string. That's a disgusting way of writing this. Let's do all words 3 contains the 4th string in the list. Okay, so that's the idea. If I use just regular square brackets, each of the elements of all words, if I use just one set of square brackets, refers to one row of this 2D array, and each row is going to be a full string. And so that's the idea. Actually, that comment doesn't clarify things, so I'm going to get rid of it. Okay, so what I'll do then is, as I read through my words from the user, I'll take the word that I was given and I'll copy it into my big bank of words. So I'll do that all words index numWords gets copied into it, the contents of the variable word. Recall with string copy, you put the destination first and then where you're copying from. And then I increment numWords. Okay, now this is already pretty complicated. How do I know that this is working? Well, I'm reading the words, apparently. I'm copying them into my big array of words, which has this number of entries. Oh, but that means I better make sure that I don't copy too many. So I better go in here and I better say that the number of words needs to be less than max words. And if you enter more than 50 words, then I'll just ignore them. So this loop stops immediately if I get to the limit of my bank of words. And now, to test that out before I begin with the anagram stuff, consider this is an anagram exercise and I haven't even started thinking about what anagrams are. Okay, so before I go further, let's print out the words that were read. Here are the words that I read. Okay, and I'll just loop over all of them. So I'll say for int I equals 0, I is less than the number of words, I plus plus. I'll just print out the words. So I'll print %s, and then I will go get all words sub I. I'm going to put the string, just like I did earlier, I'm going to put it in square brackets because I want to make sure that no extra junk got added to the strings as I entered them. Okay, I compile. I didn't get any errors. Enter some words. Okay, hello world, whatever, misspelled it. This thing, I don't know, CSE 111, done. Okay, so it read a bunch of words. Here are the words that I read. Hello, world, this thing, CSC 111. Huh, well, that'll do it. It looks like I am reading a long list of words. Okay, so fine. I'm actually going to print out how many words I read as well, just to make absolutely sure. And we'll do a couple more tests of that. Hello, world, CSC 111. That's going to be all one word this time. There's some more stuff. Done. Okay, it read 4 words. That looks good. And there they are. Okay, so I think I'm reading the words correctly. Now, let's shift gears and talk a bit about anagrams. So here's one bit of my program. I now want to write some code to decide if things are anagrams of each other. The way that I'm going to approach this is if you enter this long list of words, listen, silent, hello, world, hit, and ith, I guess what I could do is for every word in the collection, I could go and ask the question, is this an anagram of any of these other words? And it seems to me as if this would be very easy if I had a function called isAnagram. And I'll give it 2 strings. So I have 2 strings, char s1 and char s2. Or char array, so string s1 and string s2. And I'm going to return 1 if s1 is an anagram of s2, and return 0 if not. And to test this, I'm actually going to make a radical change to my program. I'm going to put aside all of the code I've written so far. I'm just going to comment it right out. I'm going to basically rewind to the beginning, and I'm going to just do a couple of very quick tests of my isAnagram function. So I'm going to make s1 equal to the string hello, and char s2 equal to the string world. And then I'm going to say if is anagram S1, S2. I'm going to print out is an anagram of this. There's S1, there's S2, great. And then otherwise, I'm going to leverage the awesome power of copying and pasting and print that this is not an anagram. Okay, so what I'm doing here is, I guess I realize that the actual test for anagrams is distinct from all this input stuff. And I want to make sure I do a lot of testing of the code I write. So I'm going to put aside the input stuff, just hold on to it for a minute, and I'm going to write a function to test if things are anagrams. I'm just building up the different parts of the foundation so I can complete the program. Okay, so right now I'm going to make this function always return 0. I'm just going to test this out. Okay, so hello is not an anagram of world. Of course, we don't actually know whether that's true or not because currently it's always returning 0. I'm also going to go and I'll test it on listen and silent eventually, but I'll use those maybe as my first test cases. It's still going to print no because I still haven't written the code for that. So yeah, it still says not an anagram. Okay, so now the question is, how do I decide if two strings are anagrams of each other? And there are a lot of ways of doing this. And I'm going to suggest, I think, doing it in a way that you might, on reflection, think is pretty slow or, inefficient or something. Here's what I'm going to try doing. Okay, so let's see. Okay, I've got my word listen and my word silent, and then they both end with null terminators, but for the sake of this exercise, I only really care about these letters. I'll go and get their lengths, although actually, now that I think about it, if the lengths aren't equal, there's no way that they're anagrams. If one of the words is shorter than the other, how could it be an anagram? So actually, already I've got one little test that I could do. So I'm going to say, let's go get the length of the two things. Int length 1 equals the length of S1. Int length 2 equals the length of S2. And if those aren't equal, if length 1 is not equal to length 2, then we're done. We're absolutely done. Just say, nope, they're not anagrams of each other. And I'm going to just put, I haven't written a formal specification for this function, but I'll just put this up here to remind myself what I'm doing. Okay, so that means that as of this line here, we can assume that S1 and S2 have the same length. All right, so now that we can assume that S1 and S2 have the same length, what does it mean for two words to be anagrams of each other? Well, there are a couple of ways I can view this. So let's think about this. One of them would be, I could say, well, if they have the same number of each kind of letter. So this word, both of these two words actually only have one of each kind of letter. But basically what I care about is if I notice that this word contains an L, then, and there's only one L in the word, then I expect that the other word contains exactly one L. And the same thing for the letter I. If both words contain the same number of each possible letter, then they have to be anagrams of each other. If I consider all of the, if they're both the same length. Now, if they weren't the same length, that wouldn't be true. But as I pointed out, as of this line, I assume that they are the same length. Okay, so here is my first approach. And this is going to be really weird. But here's my first approach. I'll actually write a loop. I'll actually write out some comments to explain what I'm going to do. Go through all of the letters in S1 for each letter. Okay, so you can see that for each, that sounds like we're going to write a loop. Count how many times the letter occurs in S1. Count how many times the letter occurs in S2. If the counts are not equal, then S1 and S2 are not anagrams. So if S1 has 3 A's and S2 has 1 A, there's no way that they're anagrams. Now, if I get all the way to the end, after looking at every letter in S1, if we never found a case where S1 and S2 are not anagrams, then just like in the earlier exercise, then by default, S1 and S2 are anagrams. So in other words, unless you find evidence that they aren't, they have to be. Okay, there's my logic. I mentioned a few minutes ago, this is inefficient or slow or something. Okay, a couple of notes about that terminology. One, that is not a good reason to not write it. I want the code to work. It's very easy to write fast, broken code. And if there's anybody out there in your life that is telling you, oh, you shouldn't do it that way, it's going to be slow, you ask them, can you make it work? If you can make it work, then we can argue about how fast it is. A lot of times I feel that there are people that program that won't solve a problem at all. They'd rather not solve the problem than write a solution that they're worried is going to be inefficient or not perfect. The issue is, generally speaking, and this is true actually like in production code. So out there, people that write code for a living, a lot of times nobody cares if the code is slow or fast. They care if the code works. And they also care about things like, is the code understandable? Although there are aspects of this process that are sort of slow, that might take more work than otherwise we need, it's not a speed problem unless you notice it. So it doesn't matter if the code is slow, unless you're sitting here waiting for the code to finish, it must be fast enough, right? If the code runs fast enough that you can use it, then the code is fine. If the code works properly, then you've accomplished something. It doesn't make any difference if the code is slow if the alternative is the code being broken. Okay, so there actually are faster ways to solve this. I can think of a clever way of solving this using CSC 116 material. In fact, anagram checking is often like a midterm question in CSC 116, but we don't have the same tools that you have in CSC 116. So we just want working code. I think that this will work. So let's give this a try. Okay, so I've got in my comments a pretty good idea of what I want. This line here, count how many times the letter occurs. This could be a loop or it could be a function. And you know what? I think I could write a function for this. And writing a function might make it a lot easier for me to understand. So I'm going to say count letter. I'm going to make a new function called count letter, and it takes a string as its argument, char s. And what it's going to do, and then it's going to be char a letter. What I'm going to do is I'm going to write a function that counts how many times a particular letter occurs. S-A letter. Count the number of occurrences of a letter in the string s. Now, I'm going to go quickly through this because it turns out we actually wrote basically the same code when we talked about 1D arrays in a few videos ago. So, okay, the count is going to be set to 0. I'm going to iterate through my string. Let's try a for loop over the string here. So I is equal to 0. As long as s sub I is not equal to my null terminator, then keep going, I++. And then at each step, if s sub I is equal to a letter, the letter that I was provided, then I add 1 to my count. Okay, and then way down at the bottom, I return the count that I came up with. So a couple of notes. One, if you wanted to write a function like this, you might want to spend a little bit of time testing that function out. Now, do I have it set up so I could do that? I guess I could quickly test that function out. Let's go try that out. I'm going to do it in main. Okay, so char s3 equals, let's make it I don't know, a word like refrigerator, which has a variety of different letters occurring at a variety of different frequencies. Or actually, yeah, okay, so let's do that. Okay, I'm going to print out, there are, let's do the letter E in the string here. So we'll do count, what's the name of my function? It's called count letter. So I'm going to see what happens if I try and count in S3 occurrences of the letter E, and then the string is S3. So we'll try that. I'll also count the number of occurrences of the letter R, refrigerator being a unique word because it contains the letter R 4 times. I'll just do this as a very quick test to make sure that my count letter function works, because if my count letter function is broken, then it'll lead to all sorts of trouble when I try and use it in something and I notice a bug later. Okay, there are 2 occurrences of E in refrigerator. Oh yeah, there it is. Okay, there's one E, there's a second one. There are 4 occurrences of R. That looks good. Let's try at least 2 more. So I'm going to do one that occurs once. I guess we'll try G for that. And then I'm going to do one that occurs 0 times. We'll do lower, well, obviously Z is the one that comes to mind, Z or X. So we'll try that. We'll just make sure that the function works correctly. And yes, this is going to take an extra 5 minutes to test, but it might save me an hour of debugging. Okay, I'm pretty confident now that count letter works correctly. So we'll just delete my test cases, we'll save my file, we'll go back up. Okay, so count letter works. That means that for these two things, I could just call count letter. All right, now I'm going to write my loop to test if I have anagrams. So I'm going to go through all the letters in S1. Now I know the length of S1. I mean, S1 and S2 actually have the same length. So I could just write a for loop that indexes up to that. So I is equal to 0, I is less than length 1, I plus plus. All right, and then let's see. So I'm going to go grab whatever the current letter, so we'll call this C. That's going to be the current letter in S1 at index I. I'm going to make 2 count variables. The count of that number of letters times that letter occurs in S1. So I'll call count letter on S1 of the character C. And then I'll do count 2 equals count letter of S2 with the character C. And then if count 1 is not equal to count 2, then I return false. So then I say, then we're done. Not an anagram. And I go back down here, and if I get all the way to the bottom without encountering that situation, that apparently means I've found no evidence that the 2 strings aren't anagrams. So one really important thing to understand here, though, is that this wouldn't work. None of this would make sense if I hadn't already tested that S1 and S2 have the same length. And I can give a quick example of why that's the case. So let's think of the word hello, and suppose S2 was this string here, ELLHOXYZ. In the logic I've given, I go through every letter in S1. Okay, there's the H. Does it occur the same number of times in both? Yes. Here's the E. Yes. Just 1 E in both. There are 2 L's in both. That's good. There's 1 O in both. That's good. And at the end of the loop, apparently, it looks like they're anagrams. But notice that there were some extra junk characters in S2 that I never even looked at. If I know that they're the same length, so if I know that S1 and S2 are both of length 5, there is no way for it to pass all of the tests unless they actually are anagrams. That's the logic I'm using. And it's having made that observation, I think, that might have made the problem a little bit easier for me. And maybe it's because I fiddled around with some anagrams by just drawing it out, or I mean, drawing it on paper, but I mean, not really on paper, but on the screen. By drawing it out and playing with it by hand, I was able to make a few observations that made my life a little bit easier. And that's usually the case in programming. The sooner you start writing code, the more likely you miss something that you could have observed by hand by thinking about the problem that might have made the code easier to write. So I believe at this point that maybe isAnagram is complete. Now, of course, I should be testing that, so I'll go down and return to my test cases that I wrote in main. All right, listen is an anagram of silent. Okay, that's a good sign. Now let's see what happens if I break it. Okay, so now I've got 2 words that are of different lengths. Okay, so listen ASDF is not an anagram of silent. What about hello and world? Okay, that's not an anagram. Okay, what about world and something very similar to world, like this? Okay, that's not an anagram. I probably should be using all lowercase for this. Okay, now what about a situation where I've got, let's try this. So I'm missing an H, but I've got extra L's. Okay, not an anagram. Okay, what about EHOLL? That should be an anagram. That is an anagram. Okay, I better test on at least one more input with more data. Let's go up here and see what it suggests. Oh, it's hit an if. Yeah, okay. I'm going to go over and ask ChatGPT for its longer list. In the longer list, it suggested astronomer and moon starer. Now, some of the things in this list are incorrect, but let's try astronomer and moon starer. That is a really cool anagram. Okay, they are anagrams. And you know what? At this point, I don't know if I trust ChatGPT, but my code has been working well enough that by this point, I trust my isAnagram function more than I trust ChatGPT. And that's nothing but a good sign. Okay, so I'm going to get rid of this testing code. I now believe that isAnagram works. So now the question is, how do I combine all these pieces together? I have my isAnagram function. I have all this code to read my list of words, but I now have to go through and create groups of words. That's going to be a bit of a thing. So I think here's what I'm going to do. So I've got all my words. So there's hello, there's world. What I'm going to do, I'm going to draw this example out by typing it because I think that's going to be faster. Okay, so I'll just type it as a comment. So here's what I'm going to do. I'm going to take my list of words. I already have my list of words. So I've got hello, I've got world, I've got listen, I've got silent, whatever. I read them from the user. The user types them in. I end up storing them in this big array. And so I'll even draw in the index in the array. So I'll just make a couple of spaces here. I'm really appreciating my decision to not draw this on the screen, but make a comment. So there's index 0, there's index 1, there's index 2, there's index 3. Just make this a nice little table here. Okay, so IDX. Okay, and now I've got this list of words called all words. So all words index 1 might be world. Here's what I'm going to do. What I figure is every single word needs to be part of a group, right? It could be part of a group all to itself, or it could be part of a group with something else. So maybe what I'll do is I've got this array of length 4 with the words in it, and I'll make a second array that contains the group number. So we'll call this group number. And in this example, I would say, well, hello gets to be in a group by itself. Maybe we'll start our numbering at group number 1. World gets to be in a group by itself. That's group number 2. Listen gets to be in a group. For now, it'll be a group by itself, because if I haven't seen this next word yet, I just think listen's by itself. When I get to silent, I'll say, actually, you know what? Silent gets to be in the same group as listen. Okay, because they're both anagrams of each other. This is my idea. I make a second array that stores the group number of each word. And then when I print it out, I just print out, if I want to print group number 1, I just go through and print everything with a group number of 1. When I want to print group number 2, I print out everything with a group number of 2, and so on. Now the question is, how do I get things into a group? Okay, here's my idea. I don't want you to think when you listen to me say this that I just made this up on the spot. I didn't see this exercise before the video began 90 minutes ago, but the technique I'm about to use is one that I use a lot in other code that I write. It's one of these sort of standard techniques that ends up in the toolkit of any programmer after a while. So what I'm going to do is this. I'm going to begin by setting the group number of every entry to -1. That's my signal to say that if, I'm just going to write this down, if the group number of a word is -1, it doesn't have a group yet. Okay, so I set every group number to -1. And then I keep track of what's the next group number I have to give out. I guess I could number my group starting at 0. I'm then going to go through all of my words. So, okay, I'm actually beginning to think of an algorithm here. So here's my algorithm. Set every word's group number to -1. -1. And then for each word, if the word already has a group, i.e. the group number is not -1, continue, or ignore the word and continue. So I just skip over the word. If it's already been given a group, then maybe somebody else did it. Otherwise, assign the word to the next available group. Okay, and then, maybe I'll write it, for every other word, for every other word, okay, I'll give the word a name. For each word W1, for every other word W2, if W1 and W2 are anagrams, add W2 to the same group. All right. Okay, so here's the idea. If I go through this example here, I'm going to add 2 more inputs. So here's stop and post. And actually, I'll put something between them so it's more obvious what I'm trying to get at here. And so okay, we'll go up here. It suggests hit and if. Okay, we'll just do if. I got to learn what if means. Okay, so stop. Okay, so if we begin in this situation here, where every word has a group number of -1, here is my idea. And actually we'll do, okay, I know I keep changing my mind about this. That's the problem with live recordings and no script. I'm going to add one more word. I promise that's the last one until I change my mind next time. Okay, so every group number is set to -1. That's the first step of my algorithm. Now, I'm going to go through each word, and the following protocol will be observed. If the word, so I'm going to start with the word hello. If it already has a group, which is to say that the group number is not -1, I ignore the word. Okay, but I don't do that because the word doesn't already have a group. And actually, maybe I can say, I'm going to rewrite this to make it a little bit more clear now that I know what I want to do. If the word does not already have a group, that's all I really meant. Those two steps were a bit convoluted. I can write it like this. If the word does not already have a group, and that means i.e. if group number is -1. Okay, so that makes it a little bit easier to understand. So I asked the question, does this word not already have a group? And the answer is it doesn't. There is no group already. Its group number is -1. So I go on to the next step. I now look at every other word. So I give this word the next available group number, so 0. I look at every other word and I ask, is this an anagram of hello? No. Is this an anagram of hello? No, 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 no. Okay, so I'm done. Okay, then I go to the next step. For each word W1, okay, I look at the word world. It doesn't have a group. I give it a group number. I now go ask, is this an anagram? Nope, 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 nope. Okay, so I'm done. I go to the next word, W1, listen. Okay, doesn't have a group. Give it a new group. There you go, group number 2. Okay, so now I ask, I go through every other word and I ask, is it an anagram of listen? Okay, hello, nope, world, nope, silent, yes. Okay, so it says if W1 and W2 are anagrams, add W2 to the same group. So I add silent to group number 2. Is this an anagram? Nope, 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 nope. Okay, I'm now done with the word listen. So I'm now back here again for W1 to be equal to silent. But in this case, silent already has a group. Its group number is not -1. So I don't do the next step. I skip over it. I get down to the word here. So my word W1 is now going to be the word stop. Does it have a group number? No, it doesn't. So I give it the next available group number. That would be 3 in this case. And I ask the question for every remaining word or every other word. Is this an anagram? No, 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 yes. Okay, the word post, which would be W2 in this case, is an anagram of W1, the word stop. And so I add that to the same group. That would be group 3. Same with tops. Okay, add that to group 3. I go down here. This does not already have a group. I give it a group number. I look at every other thing, and it's not an anagram of if. And so I leave it. I look at post. It already has a group number. I look at tops. It already has a group number. And now I've divided up all of my words into groups. I've got some groups that have size 1. I've got some groups that have size 2. And I've got some groups that have size 3. All that remains is to find some way to print out those groups. And I think that's a little bit easier. Okay, so I think I've got what I need. Let's take my algorithm. I'm going to go down here, and I'm going to paste it in right where I do right where I want to do that calculation after I have my word list. I'll put it in a comment. Okay, so I'm going to need a group number for every word. So I'm going to make an array to store the group number of every word. Int group number. Group number, and then I give it the size, well, I want 1 for each word, so I give it size num words. I'm going to write a loop to set every group number to -1. Okay, so I equals 0, I is less than num words, I plus, and then, okay, didn't do that. Okay, and then I do group number sub I equals -1, and then I close this off. Okay, so I've now done this step here. And now I want to loop through every word. We'll call that word W1. Okay, so I'm going to use the same basic loop because I'm just looping through all the words. And then I'll make up a, so W1 is equivalent, is the entry all words sub I. So it's word number I. And I could make a variable, like a pointer to it, but I don't know that we have the appetite for that. So I'll just keep in mind, when I talk about W1, I'm talking about all words sub I. Now, I want to ask the question, does word I already have a group? Well, okay, I go look under the group number for this particular word. And if it doesn't already have a group, then I continue and do this step. So I'll ask if group number of I is equal to -1, then I want to do the remainder of that step. That would be all of this stuff. So I assign the word to the next available group. Okay, I don't already have a way of tracking that, so I guess I'll do that. So I'll say int next group equals, well, we'll start at group number 0. Okay, so when I make up a new group, I assign group number I to be next group. And then, because now I've just created a new group, I increment the next available group. So once I've used group 0, next group is going to be group 1. Okay, so I've now done that. That's this part of my algorithm is now done. And then I have to iterate over every other word W2. There actually are some simplifications. I could actually start at index I plus 1, but I'm not going to. I want the code to work. There's plenty of time to make it faster later. So I'm going to use index J. I'm going to loop over all possible words, and it does say for every other word. So I guess I can skip over word I. So I guess I'll do something like this. If I and J are equal, then just, or whoops, nope. If I is not equal to J. So I don't bother comparing the word to itself. When W1 would be all words I. I want to talk about all words sub J, all of the other words. I don't want to worry about I and J. If I and J are the same, I'm just comparing the word to itself. So I'll just consider the case where I is not equal to J. And then I have to ask the question, if is anagram of all words I, that would be W1, and all words J, that would be W2, then I found my anagram, and it says, so I'm just going to quickly, W2 is the entry, all words J. If all words I and all words J are anagrams, then I add W2 to the same group as W1. So W1 would be index I. So actually, why don't we'll make a variable for that. So int this group equals the next group index. And I'll set group number for I to be this group. Okay, so I now add group number J equals this group. So add all words J to the same group as all words I, i.e. W1. Okay, wow, this is a lot of stuff. And I might really have wanted to try and test it halfway through, but it's hard to know how I could have done that. Although what I have here is 4 nested layers of if statements and loops, it doesn't seem like there was any natural point in the middle for me to stop. So this is a rare example of somewhere where I might have to just bear with it and try and write all the code and then see what happens. I could have tried compiling though, because if I have a compile error, it would have been a lot easier to fix if I'd done it a bit earlier. So I'm going to try compiling now and hope that I haven't gotten myself into trouble. It looks like I haven't. Okay. I'm not done the exercise, but I now have to at least print out, I'm going to print out all the words again, and I'm going to print them out with a group number. So I'm actually going to take this whole stack of code and bring it down. So here are the words that I read with their group numbers. All right, so I print out the string, and I'll print out its group number, and I'll use the same index for both. So group number I. Okay, I'm going to hold my breath. I'm going to hope it compiles. And now I'm going to try running it. Enter up to 50 words and end the list with the word done. Okay, so hello, world, listen, silent, post, if, stop, and pots. Done. Let's take a look what we got. Hello is in group 0. That looks good. World is in group 1. That looks good. Listen and silent are in the same group. They're both in group 2. Post is in group 3. If is in group 4. Stop is in group 3. Pots is in group 3. This is what I want. Okay, so what I'm going to do now is I'm going to go back and actually, before going any further, you used a couple of strange words above. What does if mean? And also I noticed it said pleep. I'm going to ask it about that too. What does pleep mean? Oh, it's apologizing. That's too bad. Okay, it really said a lot of stuff there. It seems there might have been some errors. Oh no, if and pleep aren't valid words. Okay, well, we've got to think of a meaning for if and pleep. Okay, anyway, I'm going to pleep back over to my code here. So what I have is I'm able to print out the words and their group numbers. What I need to do now is print them out in the format I have to, which is I have to print them by group. But I think I know what to do. What I'm going to do is, oh, okay, I guess the numbers are supposed to start at 1. Okay, I'll work on that one last. I think what I'm going to do is, I know how many groups there are. I've got this variable to keep track of how many groups there are. What I will do is just loop over all the possible groups and then go through the words and print out any words that match the group number I'm working with. Okay, so let's do this. For each group number G, loop over the words and print out any words with group in group G. That's what I want to do. So how many groups are there? Okay, I've got this variable called next group, and the idea is next group is the next index of a group I'm going to create. So in other words, if there are currently 5 groups, the next group, or sorry, nope. If I currently have groups 0, 1, 2, 3, and 4, then next group is going to equal 5. If I currently have groups 0, 1, and 2, then next group is going to equal 3. Now maybe you notice a familiar pattern here. Next group is equal to the index of the next group I'm going to create, but it's also equal to the total number of groups that I have. Okay, so if I want to know how many groups there are, I just iterate up to next group. And actually, to make this even more obvious, I'm going to rename the variable numGroups. And I'll just update it everywhere here. I'm going to make sure it still compiles so that name change didn't break anything. Okay, line 140. Okay, I've got the letter F here. That's fair enough. We'll try that again. Good, okay, so I changed the name to numGroups. So for int G equals 0, G is less than the number of groups, G plus plus. I'm going to print out, I'm going to scroll way up, and I'm going to print out anagram group. Okay, so I print out anagram group something. Okay, and then I'll print out the value of G. And then I loop over all the words, and I print out any words in group G. So I've got this loop I keep using to print out all the words. I'll just paste that. And I want to ask the question, is word number I in group G? So I'll say if group number of word I equals G, then I want to print the word out. Okay, so I print out the word. That would be all words index I. And when I'm done doing that, after I'm done printing everything in the group, I print out a new line. Now, I don't know whether you, maybe I wouldn't have noticed this until I ran it, but I'm going to print the group out. I wrote a printf with no \n up here, so I made a note to myself, I probably need to put a \n somewhere before I'm done. So I save, I'm going to run it. Okay, let's try hello and world, and listen, and pleep, my new favorite word, and silent, and apple, and pots, and ith, my second favorite word, and tops, and post. And I type done, and then it says, anagram group 0, hello, 0, Group 1, world, group 2, listen, silent, okay, I think I know what happened there. Pleepable, okay, so what I need to do is put a space between the two words, or between groups of words on the same line. There's tops and post, oh, oops, I wrote posts. Oh yeah, okay, so that was my mistake. I should have written stop there. The code is behaving correctly. So I noticed 2 problems. One of them is the words are getting mashed together. That can be fixed by putting a space between the words when they get printed. The other one is that the group numbers start at 0. Okay, there are a couple of ways I could address this. One of them is I could scroll up and modify my code to start with group number 1, but I'm not going to bother. What I'll do is just when I print the group number out, I'll just print it out with 1 added to it. So when I'm printing group 0, it calls it group 1. When I print group 1, it calls it group 2. And the user doesn't know what my code says, so the fact that I'm using a different numbering internally shouldn't make much of a difference to them. All right, so we'll try it again. Hello world, stop, pots, pleep, apple, ith, hit, listen, tops, and silent, and then maybe some junk just to be sure. And then I type done. Okay, anagram group 1, hello, world, stop, pots, and tops, pleep, and apple, ith, and hit, listen, and silent, and then ASDF. That's looking pretty good. I can keep testing, and I mean, maybe I want to, but here's where maybe I'll ask my colleague to give me to help me out a bit. Okay, so it's going to give me this huge list of input to play with, although this is the list, it says, this is the list it made up after it learned that pleep isn't a word yet. I'm going to go back and copy the list it gave me originally where it uses pleep and ith because I really like those words now. We'll just scroll up here. Okay, there we go. Actually, I just hit copy. So one advantage of using scanf to read my input is that even if I paste in stuff that, so I'll just do Control V. Yep, it just pastes in this huge list. Scanf allows you, when you read words with scanf, it doesn't mind if you put spaces or new lines between them. So I can paste in this whole big list with new lines between it, and then I type done, and we'll see what it does. All right, so anagram group 1, stop, tops, and post. Hello, world, listen, silent, inlets, and listen. Okay, so I think listen was in that list twice. Let's take a look. Yeah, so in the list ChatGPT gave me, the word listen actually showed up 2 different times. You can see how immediately I noticed and went and looked, because obviously if my code is duplicating it, that's a problem for me. But this is a problem for ChatGPT's input list. The word was actually there twice. Dear, dare, and read, apple and pleep, care, race, and acre, earth, heart, night, thing, glisten, astronomer, moon starer, reliant, restrain, gathers, and hamburgers. And you know, because the input is so long, we've done tests with groups of size 1, with groups of size 2, with groups that are larger in size. I think there was at least one group of size 4. We've noticed that it works if there are a small number of groups or a large number of groups. I think at this point, our testing is done. And wow, we ended up with the file's 150 lines long, of which maybe 30 lines is comments. So more than 100 lines of code spanning all sorts of weird stuff. We talked about input with scanf. That was a whole big thing. We'll learn a lot more about scanf in the coming weeks. So if scanf went over your head, never fear, we'll get there. We talked about a whole bunch of different ways of manipulating strings. We also actually got a chance to talk quite a bit about organizing data. This gimmick that I made up, where I use a separate array to keep track of group numbers, that's a completely different angle than just strings. That's not really a string exercise thing. That's just a matter of, I've got some data, I want to solve a problem, how do I keep it organized? And the technique I used, as I said, is a pretty standard technique that even you will probably, it'll become second nature even to you after a while. So if you didn't notice it at first, again, never fear, we're getting there. But what I will point out is that we're coming up on a point in the course when we'll begin talking a lot about organizing our data. If you try this exercise yourself, maybe 2 or 3 weeks from now, so at the end of November, once you know about structure types, and maybe once you know about linked lists, you will probably find that the exercise is a lot more tractable. It's a lot easier to figure out if you use some of those advanced features. One of the reasons this turned out to be a bit of a thing was that I was forced to solve it using only techniques we already know. So things like using arrays and strings. And then one last note, for most people, this construct here, I mean, if you were one of those people, I probably lost you 40 minutes ago and you're not watching anymore, but for most people, this construct here, this weird 2D array of char that I am able to treat as an array of strings, that's considered pretty alien to most people at first because it leverages some pretty weird aspects of the way that arrays work in C. So if you lost me there, again, never fear, because once we learn about structured data, you won't have to make arrays of strings using this notation. You'll be able to use a much cleaner notation to make arrays of strings. And by the end of the course, I think everybody will be able to solve a problem like this one once you've done all the clarifications in probably a less difficult way than what we did today. Okay, now I don't find myself saying this often, but I think that's enough C programming for me for the day.